Okay, so before we move on and go to the next method of solving systems of equations, which is elimination, I want to do a quick review of solving by substitution, just to make sure everyone is 100% clear on that method, and go over a couple of the questions that were on your assignment. So let's start off with number 7 from the assignment from last week called Systems of Equations Substitution. If you remember, the first thing that must be done is one of the equations has to be solved for one variable. So if you worked these problems differently than me, that is okay. There's multiple ways to work these and still get the correct answer. As long as you do all the math right, you will still come up with the correct answer, whether you solve the first equation for x, or the first equation for y, or solve the second equation for x, or the second equation for y. Lots of different options, same process, regardless of which way you did it. So we're going to use the substitution method. I'm going to solve the first equation for y. So I have negative 4x plus y equals 6. I see that there is no coefficient and y is positive, and that's why I chose to solve for y. It's going to give me less steps. So I will add 4x to both sides, and I get y equals 4x plus 6. So I'm going to be using this equation and this equation. Now that I know that y is the same thing as 4x plus 6, instead of writing y, I'm going to write 4x plus 6. I'm going to substitute this information in for y. When I do that, I get negative 5x minus, remember that the entire expression has to be written in parentheses because all of this is y. So this actually ends up giving us a negative 1 that needs to be distributed through the parentheses. Okay? This one causes problems for some people sometimes. You got to recognize that that's a negative 1 coefficient on the y. So the negative 1 is going to need to be distributed through the parentheses. So that gives me negative 5x minus 4x minus 6 equals 21. Okay? Now I have some like terms. I'm going to combine my like terms. So I have negative 5 minus 4x, which gives me negative 9x minus 6 equals 21. I'm going to add 6 to both sides. I have negative 9x equals 27. And then I will need to divide by negative 9. So I've found my x value here. But remember, the solution to a system of equations is the point of intersection. This is not a point. This is only the x value. I need the y value. So I take my negative 3. I know now that x is negative 3. So instead of writing x, I'll just use the first equation. Doesn't matter which equation you could use. You could use either. And actually you could even use this one where y, it's already solved for y. So let's do that actually. Let's use this equation. This is just one of the original equations, but solved for y. So instead of x, I'm going to write negative 3. Okay, so that's going to give me y equals 4 times negative 3 plus 6. 4 times negative 3 is negative 12 plus 6 is negative 6. Now I have my y value. I must write my final answer as a point, x comma y. Negative 3, negative 6 is the solution to this system of equations. This is the point where these two lines intersect. Okay? All right, let's also look at number 11. Number 11 was x plus 3y equals 1. And negative 3x minus 3y equals negative 15. I'm going to start by solving the first equation for x. I see that x doesn't have a coefficient, so I know that that's going to be the easiest one to solve for. And all I'm going to do is subtract 3y from both sides, and that gives me x equals negative 3y plus 1. Remember to be real careful with signs. We always got to be real careful with our signs. This is a positive one. Because I moved across the line, I changed the sign, so the 3y is negative. So I'm going to be plugging this in for x. X is equal to negative 3y plus 1. So I'm going to put it in x's place. I'm going to rewrite this equation with everything plugged in. Negative 3. Remember, this must be in parentheses because I need to multiply the negative 3 times everything that is x. And x is all of this. Minus 3y equals negative 15. I'm going to start with the distributive property. I need to distribute negative 3 through the parentheses. So I end up with 9y, negative times negative gives me a positive, minus 3 minus 3y equals negative 15. 9y and 3y are like terms. 9 minus 3, 6y minus 3. I'm going to add 3 to both sides, so negative 15 plus 3 is going to give me negative 12. And divide by 6, and I get y equals negative 2. That's the first half of my answer. I need to plug that back into one of the originals to get the second half. So I'm just going to plug it into the first equation. I have x plus 3y equals 1, and I know that y is negative 2. So I'm going to take that negative 2, and I'm going to plug it right in for y. I get x plus 3 times negative 2 equals 1. X minus 6 equals 1. I'm going to add 6 to both sides. And x equals 7. My final answer is the point 7, negative 2. Okay? All right, let's do one more using the substitution method. Solving the system, looking for the point of intersection using the substitution method. In this equation, I can see, and in this problem, I can see that one of my equations is already solved for y. So that took that part out for us. So it's already solved. I know that y is equal to 2 minus x. I'm going to plug it in right here. So I end up with x plus 2 minus x equals 2. This is like distributing a positive one. That doesn't change anything at all. So I just have x plus 2 minus x equals 2. I have some like terms here. X minus x. X minus x give me 0x. So those just canceled out. I end up with 2 equals 2. If all of the variables cancel and I have a true statement, there is an infinite number of solutions. Infinitely many solutions. That is because these are two lines that are laying on top of each other. So they are touching in every point on that particular line. Therefore, there are so many solutions. There are so many points on that line, we couldn't list them all. Infinitely many solutions. Remember that if you're in this situation and your variables cancel and you have a false statement, that would be no solution.